On to part 3 of non-Mendelian genetics, which will be sex-linked traits. Now, with sex-linked traits, what that means is that these traits, these characteristics, are located on the same chromosomes that determine your gender. These chromosomes that determine your gender are the 23rd pair of chromosomes. So remember, humans have 46 chromosomes. There are 23 different pairs, so there's 23 different types of chromosomes. And that 23rd pair is going to be an XX if you're a female and an XY if you're a male. Now, we could actually call sex-linked traits X-linked traits because the majority of these traits are all located on the X chromosome, not on the Y. Now, when it comes to these sex-linked traits, we're going to see some patterns, of course, when it comes to gender. So this is going to be the only type of Punnett squares where you're going to have to show gender. All of the rest of the traits that we've talked about, you don't have to show gender, but here you have to. So every time you work out a Punnett square, you're going to have to not only put down your letters, like in this one, we're looking at fruit flies and some W's. You're going to have to put in the X's or the X and Y's if you're talking about a male. Now, eye color in fruit flies is a pretty common sex-linked trait. So if you take genetics either as part of a biology class in college or you take genetics all by itself, you're probably going to do this experiment with the fruit fly eye color. Now, another example we'll look at is color blindness in humans. Okay, now again, here we have fruit flies. Now, fruit flies, that's something that we have to contend with. You've seen them. They look like little tiny gnats. If you look close enough, you'll be able to see that there are some that have red eyes. Most of them are going to have red eyes, but there are some that have white eyes. Now, red is going to be dominant to white, but again, this is a sex-linked pattern, so it depends on whether it's a male or a female because this trait is only on the X, not on the Y. Another example is male pattern baldness. So you can see that. Good hair. Whoops. Now, male pattern baldness, you could see here is more closely associated with males because of their X and their Y. So the issue with that is, boys, you only have one X, so you only have one shot at this. So if you are X big B, Y, you're good to go. You're going to have nice full hair, hopefully. Um, if you're X little b, Y, sorry to tell you, but this is your fate. So you have a 50-50 shot. Now girls, now females can become bald. Doesn't always have to do with your chromosomes. There are other underlying factors that could cause that, like thyroid issues. But females have two X's. Now one of these X's is inactive, so it's called X inactivation, but we have two shots at this. So females can be homozygous dominant. So X big B, we're golden, we have hair. Females can be carriers, that's heterozygous. So that's X big B, X little b. So again, big B, little b, we're safe. We're carrying the allele for baldness, but we've got hair. But a female could be X little b, and then she would have this male pattern baldness. Other examples, color blindness. We'll work out some crosses with color blindness. You may have colorblind people in your family, and now you know how to work out crosses, or you will know how to work out crosses to figure out who might become colorblind or who has the chances of having kids who have colorblind, and hemophilia. So I'm going to show you how to work a cross using color blindness. So capital C is going to be normal vision, so it means you know your colors. Lowercase c is color blindness. So what we're going to take is we're going to take a carrier female. So female is XX. You have to put that down first. And then the letters for the trait itself, you can anchor them up top, so you can superscript, you can subscript them, however you like to do it. So carrier female is heterozygous. She's X big C, X little c. And we're going to marry her off to a male that is normal vision, X big CY. Now the Punnett squares are going to work out the same they always do. One parent on the left, one parent up top. Let's see what happens. So box number 1, we've got X big C, X big C. Box number 2, X big C, Y. Box 3, X big C, X little c, and box 4, X little c, Y. Now with this one, we're going to look at males and females separately. So I've got the girls separated from the boys. All right, so for the boys, the phenotypes, we have this guy right here. So we've got 50% that are normal vision. They can match their clothes. And then we've got this guy over here, and we've got 50% colorblind. So those are the chances of the boys in this family. And then their genotypes, X big C Y, and if you notice, there is not a little c anchored on that Y because the trait isn't on that Y, so we can't put it there. And then the recessive, the X little cy, so this would be the one that would cause them to be colorblind. Now for the females, phenotype, they're all going to be normal. Now, we do have the possibility of having some carriers, which means that she could then carry this on to the next generation of boys in this family. So something to think about with this, when you're thinking about color blindness or the hemophilia or the male pattern baldness, when it comes to boys who you're inheriting these traits from, it's who you inherit your X from, and you inherit your X from mom. So it's really mom's family that you need to be looking at, not dad's, because dad gives you a Y. That Y does not have this trait on it. And then to finish out the girls, she is homozygous dominant. She could match her colors all day long. And she is normal, but she's a carrier. So the next generation of boys may not match their clothes very well. Now I have a couple practices for you to do, and then once you've completed them, then we'll go over them. So another one with color blindness. This time we're going to take a normal color vision female and marry her off to a colorblind male, and we'll see what happens. And then hemophilia. Now, hemophilia is a situation to where someone doesn't have the appropriate proteins that they need for blood clotting. So sometimes they're referred to as free bleeders. So this can be a very serious situation. This could be fatal. So what we're going to do with this one, we're going to do a couple of them. So we're going to take a carrier female and marry her off to someone who is normal, so they can blood clot their blood normally. Now she can too, but she's a carrier, so she's heterozygous. And then we'll take a carrier female and marry her off to a man who has hemophilia, and we'll see what happens. And last but not least, I do have a little color blindness test here for yourself that you can take. Now there's multiples of these that you can find on the internet. There's oodles and oodles. But with this one, what you're going to be doing is looking for the numbers that you can read in this scatter pattern of colors. And when you click on it, it should be able to tell you if you're colorblind or not. So you go ahead and read through them, see what you see. I know what I see. And then this test was for red-green color blindness. So again, just one kind of color blindness. And based upon what you get in your numbers here in the scatters, this will be normal vision, and this is the red-green color blindness vision. All right, so work on your problems, and then we'll go over them.